Okay, so good morning once again, no? So this is CS1130 for section 4-310. This is a combination of this is supposed to be for IS students, no? But currently this is a combination of computer science and BSIT, and there's one data science major, no? Do you follow? Two data science majors. Okay, okay. Uh, have you logged into our Daigler site? Our Daigler site, it's here, no? We have a course syllabus, but it's not yet very updated, no? Uh, uh, the syllabus that we will follow is the set of topics. The outline that we will follow is the topics, no, listed in our Daigler site. Okay, so this is introduction to computing. Okay, what is this course all about? This is a sneak preview. Most of you are freshmen. Okay, so this is an overview of all the Milyabe. Did I check Milyabe? Yes. This an overview of most of the majors that you will take during your 4 years in designated course, no, in the computer studies division. Do you follow? So this is your introduction to the whole course. This is an overview course of all courses that you will take. So all major subjects, most all, no, mostly all of the subjects that you will take. So if you take a look at our outline, of course we will start with the history of computing. We will define what computing is, no? And then I suggest that you look at the videos, no, of these crash courses, no, for early computing and yeah, others, no. That's because this is an overview of all the things that you will take during your 4 years, no. So you will not be surprised when you go to your actual class. So we will have a history of computing now, and then we will try to look at the structure of popular computers in the past, no, the most important computers, no, because computers evolved, no, they were not invented, but they evolved. In order to understand the structure, you will be studying the evolution instead. Study how things came to be rather than what they are right now. Okay. Now, we will record our meetings. I have already recorded the meetings with with the other classes. No, they come in different schedules. I'm hoping to by next week not to merge some of the schedules because there will be 3 recordings every time and uh, slightly different recordings. No, I'd like to make this uniform. I hope our schedule allows. No, I hope we can have a schedule maybe on a Friday, but we will do that next week. No, for the moment we will follow the regular schedule. So all meetings will be uploaded. Okay, so like this, you can right click and then open on a new tab or on a new window. So you can. So those who are not present, no, if you are not present on that particular date, I will indicate the date of the recording like this. We have July 14, 4301, and the topics. Okay, and the description of the topics that we discussed, like this is course introduction, history of computing, and the analytical engine, so that you will not more or less before you enter or you view the video, you will be able to know what to expect, what's inside, what is being discussed, no, in the video. Okay, so we will study the different structures of the computers, no, like ENIAC, no, and also look at the design itself because we will be going into programming, no? So we'll have, in order for us, especially in an old computer, you cannot program a computer which you do not understand, unlike today, no, you did not know about the hardware. In the past you have to study the hardware before you can start writing programs. Okay, so we have the IAS computer, the PDP-1, and the IBM 701. Okay, and then we will have a timeline of computer history. We will also study the history of IBM PC, which is the most important computer in our time, no? The IBM PC. All computers that we are using nowadays are patterned after the IBM PC architecture. Okay, they come in two parts. These are videos, no? So I recommend you study them. And then we will also mention or go through briefly, not very briefly though, no? The history of Microsoft Windows. Okay, how Windows came to be. I presume we are all using Windows, no? Whether Windows 7 to Windows 10, we'll take up. And we will take up also the brief history of internet, email, no? Chat, what happened to the internet, okay? And the history of the internet and the World Wide Web. Okay, if you have questions on computing, you can. We will have no. We will have forums, fora, different forum. For example, if you have questions that you cannot raise during the actual session, okay, they follow. You can post them in the fora so that I can read them in advance, and then answer them by the next meeting. Do you follow? No? You can post your questions like here. If you have questions regarding this meeting, you can post your questions on the first topic for CS. What is that? 4-310. Okay? Do you follow? So, pwede kayo mag-post. Now, this introductory course will be discussed again. You will have a semester of computer organization and or computer architecture. Do you follow? Somewhere in your later years. No? So, you will discuss these topics again, but in greater detail. Do you follow? May i-discuss nyo ito ulit. You will have a whole semester discussing computer architecture and organization. Okay? And then we will have formative tests. Now, you must have been oriented during your orientation, no, on how the grading system that is adopted during online learning, no, for online learning in Ateneo, no. You will have formative tests. Formative tests are online tests which you are required to pass, but which will not be used for grading. Do you follow? Only one test will be used in grading. In the end, it's called the summative assessment test. Okay? So formative tests are requirements for you to be able to take the summative assessment, which means that you are only allowed to take the summative assessment if you pass all the formative tests. Okay? And aside from that, you have to pass them sequentially. You cannot take the second formative test if you don't pass the first. You have to retake it again, no? Of course, or a different flavor of that. You cannot take the third if you do not pass the first and the second. Okay? Do you follow? No? Okay, we will study binary systems, no? Also, why is that? Because you will have a course in digital design. Okay, I'm teaching that right now to computer science students. No, for CS students, no, particularly, I don't think the IT majors will have this. Okay, but the CS students will have this. No? Number systems, you will have digital design. Okay, okay, and then Boolean logic. This is hardware, computer hardware. We will have topics on computer hardware, starting with Boolean logic and logic gates. Now, this is in preparation for digital design. I think no, all of you will take this, no, because this is a requirement for computer organization. You cannot take no the computer org without Boolean logic and logic gates. Even if you are an IT major, no, you will still need these topics because you will be taking computer org. Okay. Any questions so far? So you will have one semester of computer organization. The CS students will have computer architecture. Okay. So any questions so far? And then the computer hardware itself, no, the components of a computer system. What a CPU is, what are the external components of the CPU, what registers are, okay, what memory is, no, mag-study the memory, input output devices, okay, different types of memory, different types of storage devices. Now this is in preparation for the computer or class which you will have, okay, late in your later years. And then we will have programming. Are you all taking intro to programming now this semester? Is there anyone who's not taking intro to programming? currently, no, in parallel. I presume you're all taking Intro to Programming yourself. Okay. So we will have some repetition because we will discuss, aside from the programming itself, we will have the history of programming languages, what are the different types, and then we'll do a little programming ourselves. We'll be using a platform called Visual Studio Code. Okay. We'll be doing a little HTML, a little web development, basic HTML, no? And then we will be doing programming in JavaScript. Okay. And then I hope we can proceed to styling, no? CSS and Bootstrap. For those who are taking science and technology strand, you must have done this before, no? During your senior high. But for those who haven't taken science and technology strand, don't worry because we will take them again, no? So you will be creating a web page and you will be writing JavaScript programs. Now, at the same time, you will be passing assignments and you will be launching them in the net. In our case, we will be using free domain, no, and free site in because most of our materials come from W3 schools. And W3 schools also offer a free website and free domain, okay, on a limited size though, no, but I think the size is enough for us to upload our assignments. So you will develop your assignments and upload them to uh, W3 school spaces, no? It's the domain, the free domain of W3 schools. Any questions so far? So we'll discuss, no, we will illustrate certain programs, no, for repetition, branching, and so on and so forth. Okay. JavaScript arrays, no? So we will a special feature will be a source code for a shopping cart like Lazada and no. I'll be showing you a simple shopping cart, no, source code, which you will use in your final project, which is a summative performance test. No, you will write a program. There are there will be two bases for your grade. No, you will have a summative assessment test, and you will have a summative performance test. The performance test is a computer program which you will upload, and that will be the component of your grade. Okay, and then we'll study computer networks, and I will introduce, no, a new topic here on introduction to databases because it's a very important topic now in computer science and information technology. I think you will have 2 semesters, no, of databases, all of you. So we will discuss introduction to SQL. Okay. Any questions so far? No. I think I have to take a short break. No, I need to go to the personal necessity break. No, just a very short break, a minute or two. I'll be back. I'll be right back. Okay. Okay? Don't go away. Okay. Thank you. No. So these are the topics that we will take up. Any questions with this? Yeah. Just go. C++ ang print language gamit. No, we will use JavaScript. But I think you will you will use C++ in your other programming course. Okay? So hindi na tayo, we will use JavaScript because we will be writing web pages. We can't use C++ to write web pages. Okay? So JavaScript tayo dito, no? JavaScript. And anyway, JavaScript and C++ are very closely related languages, no? Okay, JavaScript and HTML, we will do a little CSS, no? Aside from HTML. little CSS, no, simple styling, and yes, incidentally, that will be it, no, JavaScript, HTML, and a little CSS. But we will cover as many topics we need in JavaScript because you will be writing programs like shopping carts, no, you will be writing a simple payroll program. Okay, do you follow? Bloodshed. We will be using Visual Studio Code as our, and the platform we will be using W3 Schools. You can use any other, no, site. Bloodshed programming language. What? Bloodshed C++ ba? Or C++. No, we'll not be using C++, no. We'll be using JavaScript. Okay? Why is that? Because during an online class, no, JavaScript is the most appropriate programming language. Why is that? You don't need any compiler. You only need a browser. Do you follow? No? You will only need a browser. So, and we need a web editor. So we'll use the Visual Studio Code. Okay, does that answer the question? Don't worry if it's a little different. Those who haven't used JavaScript before, you don't have to worry. It's a close equivalent of C++. Halos in fact, most of the constructs that we are going to discuss are also applicable in C++ or C sharp. We follow. The main difference is we don't have variable types so much. Mas konti ang data types dito sa ano. You don't even have to declare data types. It's much easier, okay? It's much easier, no? This is being an introductory course. But this is useful because later you will have at least 2 semesters of web development, no? Everyone, the IT people will have web technology 1 and web technology 2. I'm teaching web technology 2. And then the CS people will have advanced applications, advanced tools for developing apps, which include web apps, no? A lot of JavaScript is there, no? So ang daming JavaScript doon sa CS people. And then they will also have web technology. And you will have electives. Maybe you will have an elective in Python, in Django. I think you will have a Django elective. You will have an elective in PHP, no? So more or less you will have about 4 semesters, no, of web development and JavaScript. Okay? Any questions so far? So that is why this course is an overview of all courses of most, or rather your major subjects and electives that you will take in your whole year, or rather in your whole career as an IT or CS major. Okay? Do you follow? So we will introduce topics on SQL at the end. Very simple SQL, no? Not very complicated, but just simple SQL, no? Because you will have 2 semesters, no? Everyone, you will have 2 semesters of databases. Okay? Okay, and you will use databases during uh, development of applications in Windows. I think you will have a Visual Studio in C Sharp, and then you will also have web technologies, which will require you to use SQL or MySQL or SQL, no? And then yeah, you will have web technologies, which will require you also to use SQL and maybe PHP. So you'll have a lot. We don't have to discuss PHP because this is very close. We'll be using JavaScript anyway, no? Kasi you will have another time for that, no? Anyway, PHP, C Sharp, C++, and JavaScript are very closely related languages, no? If you can do one, there's no question whether you can do the other. Okay? Any questions? Any questions so far? Okay, I presume you're still there, no? Okay. Okay, let's start with our formal topic, no? History of computing. We'll go through a little history, no, a lot of history, no? What's the importance of history? Uh, History allows us to understand the design. Gutierrez ba? Gutierrez, where are you from? Can you chat? Gutierrez. I presume you're from Davao City. Okay. Did I miss anyone anyway? Bakit natawag ko lahat? Okay. So anyway, no? Kasi history gives us an easier way to study the design of the technology that we want to study. Like for example, you're asked to describe an ignition engine. Describe the structure of an ignition engine. It's very difficult to do because modern ignition engines used in automobiles are very much more complicated nowadays. Computerized na yan sila eh, 'di ba? So how can you do that? It will take you years, no, to study the structure. However, if you will study the evolution of automobiles, it will be much easier because you will not will go you'll do away with a lot of jargon, no, mga technical terms that we do not understand. By going through the evolution, you will understand the jargon behind, no, the technicalities behind the technology that you want to study. So in our case, if you are asked to describe the modern structure of a computer system, oh, it will take you more than a day because for example, the Core i3 itself or the Core i5 has a very complex, no, design. So we will not do that. Instead, we will study how the Core i3 or how the modern computer came to be. Little by little, we will understand technicalities. I'm sorry, no, the jargon behind, no, the different terms, little by little, until we come to an understanding of how computers work. Because of course, we are going to program them. Okay. Any questions? So that's why we need to study history. History of computing, not just computer systems. Okay, so we have the very first content there, history of computing. I encourage you to study, to go through the videos. Okay, there's a in the beginning you will have a video, a crash course in early computing. That's also about history of computing. Okay, if you have questions, you can raise your questions in this forum. Okay. Okay. History of computing. Uh, Formally, the first recorded event in the history of computing came during the modern period of world history. Anong ibig sabihin natin ng modern period dito? Hindi ito modern as in present, no? Because the modern period in world history came in the 17th century, 1642. Okay, kasi ganito yun eh. If you study world history, there's ancient history, no? There's the Roman period, no? And then there's the medieval period after the Roman period, and then there's the modern period. Do you follow? Okay, do you follow? Now, why is it called the modern period? Because it was the time when there were so many developments happened, no, for technology in general, not just computing technology, like engineering, no, the invention of the automobile in the 1700s, and then the discovery of electricity. So this all happened during the modern period. Before the modern period is called the medieval period, particularly in Europe. Okay, and before before the medieval period was the Roman period, no, when the Roman Empire dominated the world. Now, during the Roman period was, no, uh, very important period because it is where so many developments happened, no, both in all fields like medicine. No? Sino naka-discover ng medicine? Mga Greeks and Romans, no? And then chemistry, no, started with the Romans and the Greeks, no, during the birth of Christ, no, from the 1st century to the 5th century, no. 473. Formally because the Roman Empire ended in 473, no? When Europe was divided into different countries because the Roman Empire fell. The fall of the Roman Empire during the 5th century. It's called the Dark Age, the beginning of the Dark Age, because the developments were mostly contributed by the Greeks and the Romans. Sila yung gumawa ng development sa government, politics, no, medicine, mathematics, no, math and sciences, philosophy, no. So ang dami sana. Now it's a sad thing that when the Romans fell, technological advancement also experience a very slow pace, no? Bumagal yung technological development, no? I'm sorry, no? Scientific and technological development slowed down after the fall of the Roman Empire. No? Kasi sila yung ano talaga. So wala masyadong nangyayari during the medieval period. The medieval period was mostly wars, no? Between countries, between tribes in Europe. Do you follow? So, walang technical advancement during the medieval period. The medieval period was during early 5th century, no? 400. 5th century to the early 17th century, 1600. Okay? The early modern period is recognized to be during early 1600. No? During the medieval period, the main device used to calculate is the abacus. Okay? Abacus ang ginagamit. No? You know what the abacus is? Wala silang ibang calculation, no? Ganito, no? The abacus can be used to add and subtract numbers. It can also be used to multiply numbers, no? During the medieval period, meron na silang ways of counting using the abacus. Now, during the 1600s, no, most of the developments came from Europe, no? The early modern period, particularly among three nations like France, Germany, and Great Britain, no? Yung England, Scotland, and Ireland, Great Britain. Doon ang nangyari. Why? Because most of the people are there. Now, after the 1700s came the Industrial Revolution of Europe and the US, no? Where electricity was discovered, no? The automobile was invented, no? And so on and so forth. But before the US, no? During the time, the US achieved independence during the 18th century, no? 1700s. No? Where the modernization shifted from Europe to America. Lumipat sa Amerika, galing sa Europe. But before that, no, the early modern period, okay, development almost happened mostly, no, in Europe. One of the most notable was the invention of a mechanical calculator, no, called Pascaline in 1644. 1642 to 1644. The Pascaline. Let's look at Pascaline. What is a Pascaline? A Pascaline is a mechanical calculator. It's a mechanical calculator that can be used to add and subtract decimal numbers. It's just like the abacus. Kaya lang, sa abacus, you shift beads from left to right, right? Do you follow? Ganun yung bilang. In the Pascaline, you shift wheels. No? To add, you turn the wheel counterclockwise. No? Each wheel signifies a digit. The decimal ito eh. So the first is ones, tens, hundreds, thousands, hundred thousands, and this tens of thousands. No? To add, you turn a wheel counterclockwise. To subtract, you turn a wheel clockwise. Do you follow? So ganun. It's like the abacus. So it's called the Pascaline. It was invented by Blaise Pascal from France. Okay. Now after that, also during the modern period came the invention of the step reckoner. Let's look at for a step reckoner. Para din siyang ano, it's actually like also the Pascaline. Ayan. Meron na siyang crank. You don't have to turn. It doesn't have a keyboard. You still have wheels, no? Ito ang mas maganda, no? Pero meron na siyang crank. The crank allows you to do the calculation one time, no? Pag crank mo, mag-subtract siya. Pag crank mo, mag-divide siya. Or rather, add or subtract. Unlike the Pascaline, it has no crank. Now, the step reckoner is the predecessor of most later no mechanical adding machines. No, let's look for a mechanical adding machine like this. Yan, ito mechanical. This you can still see this if you are in Manila. No, you go to Binondo in the old Chinese restaurants. Meron pa rin mga ganito. It's an upgrade of a step reckoner. Meron siyang crank, no? But instead of using wheels, it now uses a keyboard. Do you follow? Meron ka ng keyboard where you can type numbers and then you crank so that you get the result. So meron ka ng ganito. It's like an odometer in a gasoline station. Okay? Do you follow? Did we record this already? Yes. Okay? So the step reckoner is an upgrade of the Pascaline, which now is able to do multiplication by repeated addition. It was invented by Gottfried von Leibniz. Leibniz is a strong advocate of the binary system. You know, base 2. We will discuss them later, no? In our later sessions. Why was he an advocate? Because multiplication and division are much easier done in binary. Diba? Mahirap kasi mag-divide sa decimal, right? Well, it's easy to do manually, but it's difficult to invent a machine that can do division and multiplication in decimal. Now, in binary, you can do multiplication by shifting to the shifting to the left. You shift all digits to the left, you multiply them by 2. You shift all of them to the right, you divide them by 2. So that's why Leibniz was a strong advocate of the binary system, because an adding machine or a machine calculating machine, it's much easier. Okay, designed using the binary system. Do you follow? So most computers nowadays all computers nowadays, no, are binary. Wala nang computer ngayon na decimal. Do you follow? Any questions so far? So 1801, no? A very important invention which is not related to computing but used for designing fabric, no? It's called the Jacquard's loom, okay? By Joseph Marie Jacquard in France, no? Let's look for a Jacquard's loom. Ganito. The Jacquard loom is used for designing fabric. Ito, this is the best I can have, no? Ito, ganito. Ganito yon. If you have threads and you have looms, they are inserted into a series of sequential cards with designated holes, no? I-insert yung mga ano dito, and then the output will be a fabric with a design. Do you follow? Merong design because the pattern of the holes will determine the design. Do you follow? Now, how did this become relevant to computing? Because people later, no, particularly the Americans, discovered that the holes there can be used to store codes. No? Pwedeng makastore ng numeric codes yung mga holes such that the arrangement of the cards is actually an arrangement of programs, no? An arrangement of commands. The first card being the first command, the second card, the second command, and so on and so forth. So we will be able to store a program in a deck of cards with codes stored in a particular pattern of holes. Do you follow? So mechanical pa ito. But later, which was formally converted into punch cards, no? So yung Jacquard's loom. We will discuss how it was used in the first computer, no? 1820, Thomas de Colmar invented the arithmeter. Ang arithmeter parang modern, uh, parang modern ito. Okay? Okay? It's just like a Pascaline, no? Pero meron na siyang mga sliding bars instead of switches. And then it has a small crank. No? The arithmeter is the first mechanical calculator which can do fully full four operations such as add, subtract, minus, divide. Okay? Do you follow? It was patented in 1851 to 1915. No? So ito yon, the early modern period. Now, all these inventions triggered other people, particularly other scientists, to discover other inventions. A very important invention came in 1822 in the Great Britain. No? Now, if you were asked, who invented the first computer? Okay. Charles Babbage. No? He is recognized to be the inventor of the very first computer. The first invention he did, it was not a computer. It's called a differential engine. Okay. The main purpose was to tabulate polynomial functions because mathematicians during those days always compute polynomial functions. No? And he was funded by the British government to invent a machine to tabulate polynomial functions. He designed a differential engine, but it was never constructed. It only was, it was just designed, no, in blueprint, but it was never constructed because the British government found it very expensive and very useless during that time. During that time, wala pa masyadong gamit. But today, no, you can tabulation of polynomial functions are very useful. No? Do you follow? You know what polynomials are if you take algebra, di ba? So, frustrated with his first invention, Charles Babbage came up with a new design in 1837. It is called the analytical engine. We will study the structure, no? Which was proposed to be the first mechanical general purpose computer. Anong oras ba tayo? Let me just check, no? Keep track of the time kasi baka we'll run out of time. Hanggang 3 p.m. Is that correct? Hanggang 3 p.m. tayo. Okay, we still have about 45 minutes. 40
Sir,
minutes.
may question ako, sir.
Yes.
Is there a difference between the functions of the step reckoner and the arithmeter? Or important lang arithmeter because commercially successful siya?
Yes, it was commercially successful. And then ang problema sa ano yung division, yung problema dun sa ano sa step reckoner, hindi niya na-implement. Multiplication lang with repeated addition. Do you follow? Yung step
So
reckoner,
division lang yung difference nila like sa
hirapan siya
functions?
mag-divide. Okay? So the step reckoner did multiplication by repeated addition. Okay? Wala siyang divider. Okay? Yung arithmeter is the first commercial successful, no? With all four operations, four functions. No? Pwede siya maka-plus, minus, divide, and no. It was the predecessor of the mechanical adding machine. Okay? The mechanical adding machine. Have you seen a mechanical adding machine? You were not born there, no? You were not born to see it. Maybe when it died, no? Before you were born. I have seen one, no? Many times, no? When I was in college, in high school, no? If you go to a Chinese restaurant, you will see those machines. No? Okay? So, yun ang the main difference, no? So anyway, to go on, what is the analytical engine? It was recognized to be a first general purpose computer. It was not a calculator at all. You can write programs for it, no? In fact, it was never implemented, no? Hindi siya na assemble. It was never assembled. It was only a design. But universities in the US like Penn State came up with they assembled, no, with the uh, modern assembly, no, during the 1990s or 1980s, no, they assembled the computer to show that the idea works. The most recent completion was in the 1900s, no. I think Penn State has one. Penn State has one. So the analytical engines that you see in museums were not assembled during Babbage time, no? Charles Babbage, no? Hindi yan na-assemble. Hindi talaga hindi talaga na-assemble ang analytical engine. Do you follow? However, no, a follower from Great Britain, a countess, no, of Lovelace. Lovelace is a place in England, no. Augusta Ada King found interest in the output of Charles Babbage. Si Augusta Ada King is a mathematician and writer. Okay? He made a review of Charles Babbage's general purpose computer and published work regarding how the machine could be used to solve actual real-life problems. So according to Augusta King, this machine is not just a simple machine. It's a machine that can be used in practical purposes. Do you follow? Ang sabi niya, in fact, no, Augusta Ada King wrote algorithms that are purposely designed to be carried out by the analytical engine. So, okay? Sumulat siya ng algorithms. And in so doing, he was actually programming the analytical engine. He wrote the first programs that were supposed to be run by the analytical engine. Actually, marami siyang sinulat. And because of that, she was known to be the first ever computer programmer. Do you follow? No? So, although she did not do an invention, she demonstrated that the usefulness of the analytical engine. Do you follow? Okay. So she was widely regarded as the first to recognize the full potential of computers, and in fact, no, the first computer programmer. So if you're asked who's the first computer programmer, it's not Bill Gates, no, it's not Steve Jobs. Okay, it's Augusta Ada King, Countess of Lovelace, no, in Great Britain. On the other hand, no, in the US, no, the US was independent during the 18th century, late 17th. Kailan ang independence ng US? July 4, 1776, no? 18th century nga. 1776. 18th century na. Now, the US was independent during the 18th century, and then it went through a civil war, no, after a few decades. And after that, during the 19th century, so many people migrated to the US. Ang daming nagmamigrate sa US from Europe, no, mostly from Europe. People from Europe migrated to the US, and their biggest problem was to count their citizens. So they had to do a census, count of their citizens. To do that, they have to do a census, and then doing a census count of over a wide country, no, is very difficult. So they have to use a machine. Then an American inventor invented a punch card tabulating machine. It's called American Tabulating. No, it's a the company, no, American Tabulating and Computing Company. To have the exact, no, Computing Tabulating Recording, okay, Company of America. That was the name, no, Computing Tabulating Recording, CTR. It was the company founded by Herman Hollerith in 1884, which was producing tabulating machines, patented in 1884, no. So the company was called Computing Tabulating Recording Company initially, and later in the early 1900s it was renamed IBM, which was known to be the first tech giant. Okay, so sinong founder ng IBM? Si Herman Hollerith. Okay, the founder of IBM. Okay. Okay. Any questions? No. Any questions? Comments? No? In case I make mistakes. So ito 'yan. Now, let's go and look at the work of Charles Babbage, no? The analytical engine. The design of the analytical engine. Ito yun. ito yung main design niya. No? There are three main components. No? If you have a program, you will have to store the program somewhere. No? The program, the formula, and the data. The program was then called formulae and data. No? Formulae and data. Why formulae? Because you have a formula and you will have parameters to the formula. Okay, like you compute the circumference of a circle, pi r squared. So the formula is pi r squared. The data will be pi 3.1419, the value of r and another r. So pi times r times r. Okay, that's a formula. Okay, are provided by punch cards. So the program is a series of punch cards using the Jacquard's loom. Do you follow? So you run the program, you run the loom from left to right, you're actually running a program. The machine would also be able to punch numbers into the cards to be read later. So it can really store also values to the cards. And it uses base 10, no? Decimal numbers, hindi binary. Hindi binary. We will study later the effect of this. No? Later, makita natin yung effect ng decimal computer. It's very difficult to implement if you have a decimal computer. So the first component is the Jacquard loom, which stores the program. Do you follow? Jacquard loom, which stores the program. Okay. And then the store. The store is the memory. During those days, they call it the store, which holds 1,000 numbers of 40 decimal digits. Okay. The mill. Okay. The mill is now called the arithmetic unit. It is the component of the analytical engine which performs 4 arithmetic operations. Plus comparisons, no? It can compare data, which one is greater than another. And optionally square roots. It's like the modern CPU. Although it's an arithmetic unit, it's like the modern CPU in a computer. In a modern computer, no? The mill would rely on its own internal procedures. So meron siyang set of functions. It has a set of procedures which to carry out some complex instructions the user's program might specify. So meron siyang instruction set. Okay? Like a programming language, it has an instruction set. Let's look at a sample program. Okay? Dito. Okay? All of this is in our regular site. Sorry, listen. Okay? So meron siyang mill. What are the basic parts? Meron siyang prime axis. What's prime axis? It's like a rotating wheel. No? It's like a rotating wheel in the arithmeter which can store a number. There are 3 sets of rotating wheels which can store numbers. No? So they're called prime axis. No? There are 2 types of prime axis, ingress and egress. So ingress is used to store input. Okay? Ingress. Egress stores the result. So if you have 3 plus 2, 3 is in ingress access 1 and 2 is in ingress access 2. And then 5 is in egress axis. Do you follow? So rotating wheels, ganito, ito, no? So this can store numbers, no? So mag-rotate ito mechanically, no? Depending on the value that is sent. And then when they are added, subtracted, or they are operated upon, the result will be in the egress axis, which is another rotating wheel, which can store a decimal value. Do you follow? No. There's also a prime egress axis which stores, the remainder in a modulo operation. Do you follow? But in a modulo operation. But during a divide, the quotient is in the egress axis. Okay? Any questions? So ganun yung the mill. Okay. There's a run up.
Sir,
Yes.
bit yan, sir. Parang primitive version of bit.
What is that again? Bit?
Primitive, yes, sir.
What's the spelling of bit? Can you chat it?
BIT, sir.
Yes. It's not a bit because it's decimal. Digit talaga ito. Do you follow? For example, each axis can have how many 50 digits long. Ito. Do you follow? Kung sa binary, 50 bits. Do you follow? But we could not call it a bit because this is not binary. No? So ito 50, if you count this, there will be 50 of this. This will be another 50 of this. Do you follow? Because we can do subtraction and addition by rotating wheels, di ba? Do you
Ay, sir,
follow?
so ang per stock yan is nag-represent ng 0 to 9 na number?
This is not 0 to 9, this is 0 to 50.
I
Oh.
mean, ang per stock, sir ba? Kasi
Yes.
decimal man kayo to, so 0 to 9 siya.
Yeah, 0 to 9 sana kung 10 wheels. Pero 50 wheels man. So 0 to 49.
Ay, 50 digits siya or like 1 to 50 siya na numbers talaga?
15 digits. Ibig sabihin 50 yung number of wheels. And each wheel is from 0 to 9.
Ay, gani sir, yung per wheel pa lang nag-represent na 0 to 9.
Yes, per wheel is 0 to 9. And there are 50 of this. Do you follow?
Yes, sir. Okay,
So,
sir. Thank you, sir.
kung 3, yung 3 itong first wheel, ang lahat 0. Kung 30, 3 yung second wheel, yung first wheel 0, lahat yung 0. Do you follow? That's how it works. Do you follow? So this can store a very, very large number kasi 50 wheels, decimal digits. So there's an ingress access 1 and an ingress access 2. These are used to store the input in a formula. Okay? Do you follow? Like the computing the area of a square or the area of a rectangle. Do you follow? So pwede. So pwede niya i-store yung results sa egress axis. No? There's a run-up lever. A run-up lever can determine whether the egress access is set. Anong ibig sabihin ng set? If it's non-zero. Do you follow? If the egress access is non-zero, the run-up lever will know that this is a 0 or not. Okay? Now, in decimal, we say a set is, or rather in binary, we say a set is 1, as a reset is 0. But in decimal, we say a set is a non-zero because we have several digits. And a reset is 0. Do you follow? No? So ito yung mill niya. Meron siyang mga primed wheels. Okay?
Anong purpose yung primed egress access, sir?
Yung primed ingress access. Let's look at that. The quotient, no, of a 100-digit number divided by a 50-digit number. So ganito 'yon. Kasi paminsan sometimes a 100-digit number is very small, 50-digit. So you can combine the primed ingress access with the ingress access 1. You have 50 wheels here, you have 50 wheels here. You can have a very large dividend. Dividend, no? You can have a very large dividend. Okay? If you have a very large value like 100-digit number, you can use the prime ingress access. Do you follow?
So in certain circumstances lang magamit pala yung
Yes, when the number
prime.
to be divided is very large. Okay?
Yes, sir. Okay, sir.
Do you follow? Ang egress axis naman, during a division, the quotient is in the egress axis and the remainder is in the prime egress axis. Tama ba ako? Oh, the remainders of division. Do you follow? So mga rotating wheels lang ito, no? Invented. This is the mill. Now, there's a run-up lever, no? We'll study the run-up lever later. Now, let's look at the Jacquard's loom because the first component is a Jacquard loom. The second component is the mill, and the third component is the store. Do you follow? There are three main components. So nowadays, meron tayong input devices, meron tayong CPU, and then meron tayong memory. Do you follow, di ba? Now, during the time of Babbage, he calls it Jacquard's loom for the input, okay? The mill for the CPU, and the store for the memory. No? So, the jargon. That's why I'm telling you, you have to understand the jargon behind all this. No? Okay. Now, if you look at the Jacquard's loom, ito yung Jacquard's loom eh. So, merong mga deck of cards. Di ba? I-process yan sequentially. from left to right so that the computer will be able to read the number. Okay. So in the cards room, the program comes as a set of cards. Okay. There are different types of cards. Okay. Different types of cards. First, there's an operation card. Okay. In an operation card, you can have basic operations. Okay. Which can do plus, minus, times, modulo, or divide. No? Do you follow? Basic operation card. So an operation card can indicate whether plus, minus, divide. No? Combinational cards used to perform loops. No? There's a CB and CF. No? Move forward and move backward. No? These are combinational cards to indicate how to move. Kasi in a program, you will sometimes do repetition, di ba? And branching. Special cards. Special cards to ring a bell or to halt or to halt in success. Diba? To finish in succession. Kasi ganito 'yon, wala silang monitor, diba? And then when a program is running, how will the operator know that the program succeeded? They will ring a bell. If no bell rang, ibig sabihin, naghang yung program. Okay? Simple idea but it works. Do you follow? Okay? Number cards. These are used to put numeric values in the store. Okay? To set the number of a store. No? Kasi yung store, pwede tayo mag-store ng number doon. Okay? So these are called number cards. Variable cards are used to transfer data from the store to the mill or the mill to the store. Do you follow? Load and store ang tawag dito. Okay? Now there's a special variable card that when the memory is full, no? Other cards are used to store values in memory. So the card looks like operation cards, number cards, and variable cards. Okay? Do you follow? Let's have an example. Ito. So first is a numeric card. Ito, numeric card. N001500. What will this mean? We will put the value 500 in the address 001 in the store. Do you follow? The first address is 000. When you say N00230, this is a numeric card. Do you follow? This puts 30 in the address 002. Divide. Divide is an operation card. Okay? Which tells the machine to do a divide. Okay? And then you'll have L001. L is a variable card, which means load a value. No? So, remember, we have operation, number, and variable cards. Okay? Okay? Okay. So load will load it's a variable card which will load a value. So ibig sabihin, if the load comes as the first load, it's stored to the axis 1. If the second load will store to axis 2. Okay? Do you follow? We'll show you that later, no? And the S will store the prime ingress with a prime, no? A plain S will store the main ingress. Okay? Egress, no? Egress. Is that correct? Yes, egress to memory. Ang ginagamit ng load will be ingress. Ang ginagamit ng store is egress. Do you follow? Okay? B will ring the bell on success and H holds the engine. Okay? Any questions so far? Sus, meron konti na lang yung time natin, no? I hope we'll finish
Sir,
this.
ang output yan, sir, kay card lang din.
The output will be in the egress axis. The final output. You will have the option to store the egress access to print because there's a print command. Okay? The P command will print the egress access to a card. That's correct, no? But it's optional, no? It's optional. You can have the output in the store also. Do you follow?
So may command yan siya, sir, na i-store siya or hindi?
Yes.
Like maglagay ka ng card para ma-store siya?
Load stands for store. Okay?
Oh.
Let's have a sample program, okay? Let's have a sample program. Para we will understand this, no? I think this is becoming interesting, no? Now, the sample program presented is the factorial of 4. Who knows what a factorial is? 4 Exclamation, it means factorial of 4. What's the nth factorial? What's the first factorial? Anyone? What's the first factorial?
1.
1. Why?
Kasi yun lang yung possible na
Because it is 1 times
backwards.
1. 1
Yes,
times
sir.
1. Di ba? 1 times 1 is 1. What is the second factorial?
2.
2. Because 2 times 1 is 2.
2.
What is the third factorial?
3.
6. Why? Because 3 times 2 times 1 is 6.
Ay, okay. 3 factorial. Okay, gets.
Okay. 3 times 2, 6. Times 1, 6. What is the fourth factorial?
24.
4.
24. Why? Because you have 4 times 3 times 2 times 1 is 24. Do you follow? So when you say nth factorial, you multiply all the first n numbers. Okay? Now I have here, I have presented this in Excel. Nilagay ko sa Excel kasi mas madaling maintindihan. Okay? Okay, ito. This is the fourth factorial in Excel. With loop and without a loop. Can you see this clearly? In your end? Klaro ba?
Yes, sir.
Yes po.
Okay? So, ganito yon. There are 3 parts of the analytical engine. First, you have the Jacquard loom. Do you follow? Sa Jacquard loom, nandun yung program as a sequence of cards. Number cards, operation cards, and variable cards. Do you follow? Now, the second component is the mill. Nandun sa mill yung ingress axis at saka egress axis. Do you follow? Yung ingress axis, dalawa. AX1 and AX2. Do you follow? This is the mill. The third component is the store. The store is a memory device which can store 1,000 numbers. The first is 000, the second is 001. These are the addresses of the store, no? Do you follow? Do you follow?
Yes, sir.
Okay. So the first command is N004. Anong ibig sabihin nito? We set store 00 a value of 4. So dito, ilalagay natin yung 4. Okay? Do you follow? Ilalagay yung 4 dito. 4 is the first multiplier. Kasi yung kanyang fourth factorial starts with, it doesn't matter whether you start with 1 or you start with 4, right? Ang kanyang fourth factorial is 4 times 3 times 2 times 1. Hindi 1 times 2 times 3 times 4. Do you follow? This is in our web Dagler site, by the way, no? Itong worksheet na ito, you can download it from our Dagler site. Particularly here, no? Uubusan yata tayo ng oras, no? Ito. Okay? You can download it from here. Okay? So ang 4 ilalagay natin dito. When we say N0011, the store 001 is set to 1. That's a numeric card. And then when we say N0021, yung store 002 will have a value of 1. You follow? In a modern language, we call this an assignment statement. Do you follow? Di ba? Assignment statement ang tawag dyan. Okay? Any questions? Now, the next card is an operation card. Do you follow? The first 3 cards are numeric cards. The next card is an operation card. What operation is stated in the operation card? It's a times, which means it will do a times. What will it multiply? First, it will multiply L002. Ang ibig sabihin nitong L002, yung nandito sa 002, ilagay sa ingress axis 1. Bakit sa ingress axis 1? Because it is the first L, which comes from a variable, from an operation card. No? Una siya from an operation card, so sa ingress axis 1. When we say L000, which is currently 4, ilalagay siya sa ingress axis 2 because it's the second after the operation card. And right away, since it's a multiplication, 1 times 4 is equal to 4. So the egress axis will have a value of 4. Do you follow?
Sir, bakit siya sa 002 nag-start? Like automatic lang siya or tayo nag-set niya na
Tayo nag-set nun.
002?
Because the first is 4 times 1. Ang una natin gagawin will be 1 times 4. Di ba? Kasi sa 4
Yes.
siya nagsimula eh. Sa 4 siya nagsimula. Hindi siya nagsimula sa 1. You can do this on the reverse. Instead of using a 1 here, we will use a 1 here and we will use a plus here. Do you follow? So 0, 0 actually stores, this values actually stores our next multiplier. Do you follow? Our next multiplier is 4. So we have 1 times 4. And the egress stores a value of 4. We will store the result of the egress as S002. Ang ibig sabihin ng S002, yung value ng egress ilagay sa 2, which is 4. So this is our partial product sa S002. Ang first partial product natin is 1. The next partial product is 4. Di follow? You can do this the other way. Depende sa programmer. Di ba? Do you follow? Do you get my point?
Yes, sir.
Yes, sir.
So ngayon ilalagay ito sa 4. Now the next card is a variable card. Minus. Okay? It will do a minus. What will it minus? 0, 0, 0. What is 0, 0 now? It's still 4. So ilalagay yung 0, 0 sa egress axis 1. And another L001. So L001 is still a 1. So ilalagay niya ang 1 dito. So 4 minus 1 is equal to 3. So the egress will have a value of 3. Do you follow? And the next command is S00. Egress will be stored to S00. So 4 na siya ngayon. So
Ay,
now,
sir.
yes.
So, ang order ng pag-process nito, sir, is first is yung operation, then yung dalawang variable.
The first is compute the first partial product. Tingnan mo, nag-compute na siya kaagad ng first partial product, di ba? The first partial product is 4. After computing the first partial product, subtract the next multiplier.
Ay, okay.
So, tingnan mo, dalawa ito eh. Dalawa ito, di ba? Times and minus, times and minus. Times is used to compute the first partial product, which is here. Nandito. Do you follow? The second step is compute the next multiplier. The first multiplier is 4. What is the next multiplier? If you start with 4, what's the next multiplier?
1?
3. 3
Ay,
ang
3?
Yes, because we will do 4 times 3. Di ba? After 3,
Bakit naging 3, sir?
Okay, factorial siya, yun yung process.
Kasi baliktad yung process natin eh, di ba? Instead of 1 times 2 times 3 times 4, we did 4 times 3 times 2 times 1. The first multiplier is 4. The next multiplier is 3. The next multiplier is 2. The last multiplier is 1.
Okay.
2 is multiply 4 times 3. Okay? And then multiply 4 times 3 times 2. Di follow? Binaliktad niya eh. It's a programmer's way, no? So pwede rin baliktarin niyo kung gusto niyo eh, di ba? Pero ang kanyang style is nagsimula siya sa dulo. The first multiplier is 4. So we will multiply 1 times 4. The first partial product is 4. Then compute the next multiplier. So 4 minus 1 is 3. So this is the next multiplier. Then next step, repeat, no? Times L002. What is L002 now? It's 4. Diba? And then 0, 0. 0, 0 is 3. So the next partial product is 4 times 3, which is 12, and we store it to 002. The next partial product is 12. Do you follow? Do you follow?
Yes, sir.
Okay.
Yes, sir.
12 na siya. Now, after computing the partial product, what will we do next? Compute the next multiplier. The current multiplier is 3.
It's 3.
So, ilalagay natin sa mag-minus tayo. Ilalagay natin sa axis 1, 3. Tapos yung 1, this is always fixed at 1. Ito, 1 talaga ito siya, di ba? Hindi naman siya magbabago eh. Do you follow? So, 3. So, 1. 3 minus 1 is 2. The next multiplier is 2. We store it at 0, 0. Ito ngayon, na-compute na natin. Right? So, we repeat the process. Compute the next partial product. The next partial product is 12 times the next multiplier. So, itong 12, ilalagay dito. The next multiplier, which is 2. Lalagay dito. So we multiply this 24 and we store the next partial product, which is 24. Are we done? No, because the last multiplier should be 1. Do you follow? And then we compute the next multiplier. We have 2 minus 1. We repeat the same process, which is 1. And then we compute the next product, 24 minus 1, or rather times 1. It becomes 24. And we're done, right? We're done because the last multiplier is 1. So we have a halt, a bell, to ring the bell to tell the operator it's done, and we have a halt. We didn't have a P. If you want a P, you can do a P. But the final product is in ST002.
Sir, what is P, sir?
P is print.
Okay.
Okay, pwede tayo maglagay ng P dito. Bago mag-sort. P. Bago mag-halt. Do you follow? In which case, the final product is in the last card.
Sir, ang pabaliktad nito na way no is like store mo yung ST000 as 1 then i-add mo yung operation.
Oo, 1. Tapos instead na minus dito, plus ka. Do you follow? You can work it out, no? Programmers have their own ways, no? Depende naman yan sa programmer, di ba? Kung anong gusto mo. Okay? You can work it out your way, no? If you like. But this programmer started with the largest number. Pareho lang naman because multiplication is commutative. 4 times 3 is equal to 3 times 4. Pwede mo namang sabihin 3 times 4 times 2 times 1. Pareho pa rin. Di ba? In computing the 4th factorial. Okay? It's just about time. No? You have questions? We have a few minutes. Now, I will record this session and post this there. And the next meeting, we will start the loop version. We will discuss the loop version. So now, you understand how the analytical engine works, di ba? Now, we will start to write other programs. No? We will write averages. We will write particularly computing the circumference of a circle, no? The area of a rectangle. Do you follow? No? Because that's what Countess Augusta Ada Lovelace did. Ada King, yun yung ginawa niya. He demonstrated that this machine could solve practical problems. Do you follow? Do you get my point, everyone? We have a few minutes, no?
Yes, sir.
We'll review this next meeting, okay? We'll review this next meeting, no? But you have to understand this because you will have an assignment on this, no? You will write your own program. I'll post the assignment next meeting. Okay? Okay? So we will be primitive programmers in the beginning and advanced programmers in the end. Because now we are using the analytical engine. In the end, we'll be using JavaScript. Okay? 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 So see you next meeting, everyone. We're running out of time. This meeting is recorded. It will be uploaded. Okay? Any more questions?
Sir.
Thank you for coming. Okay? Thanks for coming.
Thank you, sir.
Thank you for coming.
Thank you, sir. Bye, sir.
Thank you, sir.
Bye, sir.
Bye,
Thank
everyone.
you, sir.
Bye.
Thank you, sir.
Thank you, sir.